Today, we're diving into a really important effort to bring some much-needed order to the exciting, but kind of chaotic world of AI in dentistry. We're talking about a new initiative to create one clear standard for how AI studies get reported, so we can finally compare them apples to apples. So let's start with a number, 42. What on earth does 42 have to do with the future of dental AI? Now, it's not the answer to life, the universe, and everything, but it is the key to understanding a huge problem facing all of us, researchers and clinicians alike. That's right, a recent review found a whopping 42 different ways that researchers are measuring how well their AI models work. With that much variety, you can see how it becomes nearly impossible to compare one study to another. This, and this is the important part, really slows down our progress and makes it harder to get this amazing tech from the lab into the clinic where it can actually help people. So in this explainer, we're going to break it all down. First, we'll dig into this problem of 42. Then we'll decode the basic AI tasks in computer vision. We'll look at how a new standard was created, reveal the 8 core measures that everyone should be using, and finally, talk about what this means for the future of reporting in our field. You know, you could say that right now, dental AI reporting is a bit like the Wild West. There are no agreed-upon rules, no sheriff in town, so to speak. Everyone's kind of doing their own thing. And that's creating some pretty big problems for all of us. And here's why that's a huge deal. This isn't just some academic headache. When study results aren't comparable, we can't combine them to do powerful meta-analyses. We see reports that are missing key pieces of information, and there's a really high risk of what's called selective reporting bias, where researchers might, consciously or not, only show the numbers that make their AI look good. All of this just creates a massive bottleneck, slowing down that journey from a cool research paper to a tool you can actually use in your practice. Okay, so to really get why the solution works, we've got to peek under the hood a little. Let's quickly decode the fundamental computer vision tasks these AI models are actually doing. Take a look at this radiograph. We can ask an AI to do 3 fundamentally different things with this one image. It can do classification, segmentation, or object detection. And each one of these tasks answers a different question and, crucially, comes with its own challenges when it's time to measure performance. So let's break that down real quick. Classification is the simplest. It's basically a thumbs up or thumbs down for the whole image. It just answers, is a filling present, yes or no. Segmentation is way more detailed. It's like coloring in the lines, outlining the exact shape of that filling pixel by pixel. And object detection is somewhere in the middle. It just draws a simple box around the filling to say, hey, it's over here. Now, here's where it gets interesting. A simple yes, there's a filling from a classification model isn't all that useful clinically, right? It doesn't tell you where it is. To get that useful info, you need extra steps, like detecting each tooth first. But, and you can see it in the red boxes here, every extra step you add can introduce its own biases and needs to be evaluated separately. It gets complicated fast. And this slide really highlights a core technical problem. For those more advanced tasks, like segmentation or object detection, some of our most basic performance metrics are surprisingly tricky to calculate. Take specificity, for example. To calculate it, you need to know the number of true negatives. But if the AI is looking for fillings, what's a true negative? Is it every pixel that isn't a filling? The whole tooth? The background? There's no clear answer. And if you can't define it, you can't measure it properly. You're left with an incomplete picture. So, faced with this reporting chaos and these technical hurdles, a global group of experts decided enough was enough. They came together to forge a new standard, and that led to the creation of something called DentalCOMS. So, what's the big solution? It's something called a Core Outcome Measure Set, or COMS for short. And this isn't just some casual suggestion. It's a formal, consensus-driven framework designed specifically to bring consistency, clarity, and comparability to all of our dental computer vision research. And I want to emphasize, this standard was built on a rock-solid foundation. This wasn't just thrown together over a weekend. The process started by reviewing all the existing guidelines and interviewing experts. The whole thing was developed as part of a World Health Organization global initiative on AI for health. And then they used a really rigorous 2-stage survey process to get 26 international experts. We're talking clinicians, top researchers, policymakers to all agree on the final set. That's how we got DentalCOMS. All right, so this is the moment we've been building up to. What exactly is in this new standard? Well, it all boils down to 8 core outcome measures that, from now on, every single study should be reporting. Here they are, the core 8. Everything starts with a confusion matrix. Think of it as the foundational scorecard that shows every single prediction, the good, the bad, and the ugly. From that, you get accuracy, which is just the simple overall grade. But that doesn't tell the whole story. We need sensitivity. Of all the actual problems there, how many did the AI find? And we need specificity. Of all the healthy areas, how many did the AI correctly leave alone? Then there's precision, which is absolutely crucial. It answers the question, when the AI did flag something, how often was it actually right? You don't want a tool that's constantly crying wolf. The F1 score finds a nice balance between that precision and sensitivity. And finally, the two area under the curve metrics, they give us a big picture view of the model's overall diagnostic horsepower. Together, these 8 measures give us a full 360-degree view of how an AI model is really performing.
So, let's bring this all home. What does this mean for the future? Why does this matter to you? Whether you're a researcher, a journal editor, or a practicing dentist just trying to figure out which tools are worth paying attention to. Well, the clinical significance here is just massive. Adopting DentalCOMS means we can finally compare apples to apples. This unlocks the ability to do truly meaningful meta-analyses. It helps reduce reporting bias, which builds trust in the research. And most importantly, it clears the path to get these tools out of the lab and into the clinic, where they can help our patients. It also gives reviewers and editors a clear, fair yardstick to measure the quality of a study.
And hey, you don't have to take my word for it. The authors of the paper themselves put it perfectly. They said, adherence to the defined comms is expected to increase comparability across studies, enable synthesis, and reduce selective reporting. That quote just perfectly captures the goal, to build a stronger, more reliable scientific foundation for AI in our fields.
So I want to leave you with a question. Whether you're a dental researcher, a reviewer, or an innovator, as you design your next project or read the next paper that lands on your desk, ask yourself this one simple question. Is it COMS compliant? The future progress of our entire field might just depend on it.